Hello, friends. Our next topic is transmission media. Till now, we have discussed many issues related to the physical layers. So, in today's lesson, we will discuss transmission media. Transmission media are actually located below the physical layer and are directly controlled by the physical layer. You could say that transmission media belong to zero layer. As you all can see in the diagram that it shows the position of transmission media in relation to the physical layer. So before proceeding ahead, we should understand that what exactly transmission media plays the role in communication networks. If we go ahead with defining it, it is anything that can carry information from a source to a destination. Let's suppose take an example that there is a transmission medium for two people having a conversation. So in this situation, the transmission medium could be the air. The air can also be used to convey the message in a smoke signal or the semaphore. For a written message, the transmission medium might be a mail, carrier, or a truck or an airplane. So, in data communications, if we focus on the definition of the information and the transmission media, it is usually a free space, or in many situations, it could be a metallic cable or a fiber optic cable. So, depending on the usage, depending on the implementation purposes, we apply the different transmission media. The information is usually a signal that is the result of a conversation of data from another form. The use of long distance communication using electrical signals started long back with the invention of the telegraphs by Morse in the 19th century. Communication by telegraph was very slow and it was depending on the metallic mediums. So, extending the range of the human voice became possible when the telephone was invented in 1869. Telephone communication at that time also needed a metallic medium to carry the electric signals that were the result of a conversation from the human voice. The communication was, however, unreliable due to the poor quality of the wires. The lines were often noisy and the technology was unsophisticated. Wireless communications started in 1895 when Hertz was able to send the high frequency signals. Later, Marconi devised a method to send telegraph type messages over the Atlantic Ocean. We have come a long way. Better metallic media have been invented, twisted pair and coaxial cables, for example. The use of optical fibers has increased the data rate incredibly. Free space, air, vacuum, and water is used more efficiently, in part due to the technologies such as modulation and multiplexing. Computers and other telecommunication devices use signals to represent the data. These signals are transmitted from one device to another in the form of electromagnetic energy, which is propagated through transmission media. Electromagnetic energy, a combination of electric and magnetic fields vibrating in relation to each other, includes power, radio waves, infrared light, visible light, ultraviolet light, and X, gamma, and cosmic rays. Each of these constitutes a portion of the electromagnetic spectrum. Not all portions of the spectrum are currently usable for telecommunications, however, the media to harness those that are usable are also limited to a few types. In telecommunications, transmission media can be divided into two broad categories: guided medias and unguided media. Guided media includes the twisted pair cable, coaxial cable, and fiber optic cable. Unguided media is the free space. The On the screen you can see the taxonomy. Let's start with the guided media. Guided media, which are those that provides a conduct from one device to another, includes twisted pair cables, coaxial cable, and fiber optic cable. A signal traveling along any of these media is directed and contained by the physical limits of the medium. Twisted pair and coaxial cable use metallic copper conductors that accept and transport signals in the form of electric current. Optical fiber is a cable that accepts and transports signals in the form of light. Let's move ahead with the first category, that is twisted pair cable. A twisted pair consists of two conductors, normally copper, each with its own plastic insulation, twisted together. As the diagram is showing, one of the wires is used to carry signals to the receiver and the other is used only as a ground reference. The receiver uses the difference between the two. In addition to the signal sent by the sender on one of the wires, interference or noise and crosstalk may affect both wires and create unwanted signals. If the two wires are parallel, the effect of these unwanted signals is not the same in both wires because they are at different locations relative to the noise or crosstalk sources. For example, one is closer and the other is farther. This results in a difference at the receiver. By twisting the pairs, a balance is maintained. For example, suppose in one twist, one wire is closer to the noise source and the other is farther. In the next twist, the reverse is true. Twisting makes it probable that both wires are equally affected by external influences, noise, or crosstalk. This means that the receiver, which calculates the difference between the two, receives no unwanted signals. The unwanted signals are mostly cancelled out. From the above discussion, it is clear that the number of twists per unit of length, for example, inch, has some effect on the quality of the cable. Unshielded versus shielded twisted pair cables. The most common twisted pair cable used in communications is referred to as unshielded twisted pair UTP. IBM has also produced a version of twisted pair cables for its use called shielded twisted pair STP. STP cable has a metal foil or braided mesh covering that encases each pair of insulated conductors. Although metal casing improves the quality of cable by preventing the penetration of noise or crosstalk, it is bulkier and more expensive. The diagram shows the difference between UTP and STP. Our discussion in this lesson focuses primarily on UTP because STP is seldom used outside of IBM. So, we end this lesson here only. In the coming lectures, we'll be talking about the categories, connectors, performance of the cables, and we'll go ahead with the next two categories, coaxial and fiber optic cables.